Okay. Hello everyone. Welcome back to the live session on doubt lectures on engineering mathematics. And I hope I'm clear and audible to everyone. Good morning everyone. So in the previous class we were discussing the basics of probability, the axioms and the conditional probability based theorem and all those things. Right. And after that the next class was on variance and expected value, the moment, right? So we discussed all these topics, like we have already covered 2 lessons on probability and statistics, and we are into distribution now. Today we will be discussing the topic continuous and discrete distribution. We will be covering up all this like binomial, hyperbolic, Poisson's, and in continuous we'll be discussing exponential, normal and uniform distribution, right? So we'll be covering up all of this. We'll try like to finish it up today itself. Good morning, Kirti. How are you? Okay. So now that I expect like you have already gone through the basics and notes of on the topic we are going to discuss today, we'll be focusing on the questions, the previous year questions, the methods, the elements, right? So that we can make it quick while we are attempting the questions in the examinations, right? Apart from that, let's start. And for people who are joining today, they can also visit the links in the description. You may get the entire playlist of what we have already covered, and of course you can also get the code, maybe promo code like Sahu10, which will help you to get the package in a discount price or something like that, right? So please install it, please subscribe, and please get your own courses as per your streams and everything. Fine. Chalo, let's start with the questions then. Fine. So we'll start with the we'll start with discrete distribution, and in that we are starting with the binomial distribution. So as per the binomial distribution, the basic formula, I hope you are clear. Otherwise, we'll of course we'll discuss the formula and then we'll only proceed solving it, right? So in that case, let's start with the first one. So the first question says a 6-faced fair dice is rolled 5 times, and of which the probability that obtaining one at least 4 times, right? So basically in binomial we need the number of trials. So the number of trial is n equal to 5, and the number of success we are expecting is at least 4. So that means R is greater than 4. Now R is greater than 4 out of 5 trials means R can be 4 or 5, right? These are the two possible values of R out of n equal to 5. Of course we cannot have more than 5 success in 5 trials, right? If we have 5 number of trials, the maximum number of success is 5. We also know that probability of R is given as NCR, P which is the success rate to the power of R, and Q which is the failure rate as N minus R, right? So in this case, if you see, in this case we are looking for PR which is greater than equal to 4, which is nothing but P of 4 plus P of 5. And what about the success rate? Now that it is a dice, we are possibly having 1, 2, 3, 4, 5 and 6 as the sample outcomes, of which the event is to get 1, right? So in that case the success is going to be 1 by 6, whereas the failure Q is going to be 5 by 6. So for the 4 number of success and 5 number of success, we are going to have 5C4 1 by 4 into 1 by 5 plus all 5 success, that is 5C5 into 1 by 6 to the power of 5. So we need to calculate this, and this will give you the answer. It is going to be 3.34 into 10 to the power of minus 3. But what they are asking is not the probability, they are asking the probability percentage. So if this is P, the probability in percentage is going to be 3.34 into 10 to the power of minus 3 into 100%. And this is how much? 0.3, like that. So option C is the right answer, right? 0.0334 percentage, which is option C. So C is the answer in this case, right? I hope I'm clear with the number of trials, the number of success we are expecting, the rate of success, the rate of failure, everything is there. Direct formula is to be used here, which is NCR into P to the power of R into Q to the power of N minus R. Clear? So let's move to the next question then. Well, in this case, it says an unbiased coin. So unbiased coin is like the number, the rate of tail and rate of head is all same, right? That is what we mean by unbiased. So equally likely, you can say it is equally likely. The probability of head is equal to probability of tail, and overall it is going to be 1 by 2 each. So the probability that the fourth head appears at the 10th toss. So overall, this means that we are going to make 10 number of tosses, and out of which at 10th toss we are expecting a head, that is fourth head. So 10th toss gives fourth head. This is possible when we have, out of previous 9 tosses, we should have total 3 heads, and in the sense you will have to multiply and fourth head at 10th toss, right? So I hope I'm clear that if you expect fourth head at 10th toss, of course you cannot get 4 heads in a single toss, right? You can get only 1 head at one toss. So if it is the fourth head at the 10th toss, that means you are expecting 3 heads for the previous 9 tosses, and this is going to be possible, like this can happen. This is going to be 9C3 1 by 2 to the power of 9. Why I'm writing 1 by 2 to the power of 9? Because P is also 1 by 2, Q is also 1 by 2. So overall it was supposed to be 9C3 1 by 2 to the power of 3 into 1 by 2 to the power of 6. So overall it becomes 1 by 2 to the power of 9. So I'm writing it directly. And fourth head at 10th toss. So there is nothing like fourth head. Just think of a head at 10th toss. This is simply head at 10th toss. So this is possible. The probability is 1 by 2, right? Getting ahead at any toss is 1 by 2. So now for this and is like intersection. So this intersection overall probability, let's say probability of event, is going to be 9C3 1 by 2 to the power of 9 into 1 by 2, right? This is for three number of heads for the first 9 tosses, whereas this is for the exact one head at the 10th toss. So that head will be the fourth head, because we are already having 3 heads before the 10th toss out of the 9 tests, right? So this is what we need to calculate. So you can find the value. This is going to be 0.082. You can calculate this, of course, right? So calculation is not something we are going to spend time on here. So this is the answer in this case. So that is option C again. I hope we are clear again. Clear? Yes, everybody? Let's see this question then. It says a fair coin is tossed independently 4 times, right? So this number is important, 4 times. And the probability of the event, the number of times heads sewn up is more than the number of times tails sewn up. So overall number of tosses or number of trial is 4 in this case. And we have to check that the event is, let's say this is event, that the number of head is more than tail. So total number of 4 trials will give either all 4 heads and 0 tail, or 3 heads and 1 tail. After that, what will happen? You'll have maybe 2 heads, 2 tail, and maybe 1 head and 3 tails, and 0 head and 4 tails. So these cases are excluded. These are not our events, right? This comes into the sample, but this doesn't come into the event, right? Because we need the number of heads to be more than number of tails. Now this is possible. This case is like all 4 heads out of 4 number of trials. So let's say the success of head is 1 by 2, and of course the tail will be, let's say this is success. Getting a head is success, and getting a tail is, like, let's say it is a failure, which will also be 1 by 2. So out of n equal to 4, let's say r is equal to 4 and r is equal to 3 in this case. Let's say we are talking of heads, because when we don't get head, we'll get tail only, of course. So this becomes 4c4 into 1 by 2 to the power of 4, and this becomes 4c3 into 1 by 2 to the power of 4. Why I'm writing to the power of 4? Because success and failure are all same as 1 by 2. So it is supposed to be p to the power of r into q to the power of n minus r. But p and q are all same, so we can rightly write it as p to the power of r plus n minus r, that is n. Both p and q are 1 by 2. So now nothing, just add both of it. That's it. That will be the answer in this case. So your answer, the probability is, let's say event 4C4 is going to be 1, and 1 by 2, that is 16, plus 4C3 is 4 by 16 again. So this is 5 by 16, which is option D. So D is the answer in this case. I hope I am clear again. Clear? So this is how we are going to get it. The number of heads to be more than number of tails. So now we are into hypergeometric. The binomial, we covered like 3 questions on binomial. Now we are discussing hypergeometry. It says the security system at an IT office is composed of 10 computers. So total number of computers 10, let's say, of which exactly 4 are working. So let's say 4 are in the working condition. So that means that 6 are non-working condition. To check whether the system is functional, the officials inspect 4 of the computers picked at random. That means overall they are inspecting 4 computers, right? They inspect 4 of the computers. That's what it is written, at random. The system is deemed functional if at least 3 of the 4 computers inspected are working. That means we are expecting R to be greater than equal to 3 in this case. At least 3 out of the 4 computers inspected, if at least 3 is working, we'll say that the system is deemed functional, right? That means the possible case is either 3 working and 1 non-working is picked, or 4 working and 0 non-working is picked. These are the 2 possibilities we can expect here, right? So this case is like picking 3 working computers out of 4 working computers. So the combination says 4C3 into, because this is 3 working and 1 non-working, whereas this is OR. So this is one case, or 4 working and 0 non-working. So you are getting the case. This is case 1, this is case 2. So for case 1 and case 2 we are putting OR, the condition of OR. Whereas within the case we have an intersection that there should be 3 working and 1 non-working. Case 2 says 4 working and 0 non-working. So it is intersection. Whereas case 1 and case 2 are union. This is union, whereas I'll mark it. Let me use something else. This is union, whereas this is intersection. This is also intersection, right? So this comes out to be 4C3 into 6C1. Why 6C1? Because we are picking 1 non-working out of 6 non-working, and in this case we are picking 3 working out of 4 working. And what is the total overall case? So the overall case is 4 computers out of 10 computers. So this is 10C4. Whereas in the second case, I am writing it here, we are picking 4 working computers out of 4 working computers. So this is 4C4. It is like picking 4 items out of 4 items into 0 non-working computers out of 6 non-working computers. So this is 6C0. And what is the overall sample? It is 4 computers out of 10 computers. That is the inspection. 4 inspection out of 10 inspection. So 10C4. So what we have to do is add both of it. Make sure that this is intersection, this is also intersection, whereas this is union. This is union. So this is going to be, do we have fill in the blanks. So first we have to find the value of P, then we have to find the value of 100P, right? So I'll give you the values. This is going to be 24 by 210 and this is 1 by 210. The sum of these two is of course 25 by 210. So P comes out to be 0.1190, whereas 100P which is asked in this question is 11.90. This is our answer. They are talking about 100P. We can say that this is the percentage value, like 100 times, so you can say it is percentage. If not mentioned, just write what is 100P. That's it. I hope I'm clear. I'll repeat it once again. It is about inspection of 4 computers out of 10 computers. So this can be done in 10C4 ways. It is like picking 4 items out of 10 similar items, right? Now, out of these 10 computers, we have some 4 working and 6 non-working. And they want the total number of working computers to be greater than 3 so that the system is deemed to be functional. So this is possible when 3 of the working or all 4 of the working systems are taken out. So it is like picking 3. It is like picking 3 working out of 4 working. So this can be done in 4C3 ways, and 1 non-working out of 6 non-working, which can be done in 6C1. And the sample which was already given as 10C4. We have already discussed this. So this was case 1. And case 2 says all the 4 are working out of the 4 working. So this is 4C4 and 0 non-working out of 6 non-working. So this can be done in 6C0 ways. And the sample is 10C4. And these two cases will be union. That is, we will have to add them. So the sum is 24 by 210 and 1 by 210. So this is the value we are getting. I hope we are clear now, right? So if we are clear, we can probably, I think this next question will be easier now. Let's see. A box contains 25 parts, of which 10 are defective and 2 parts are being drawn simultaneously in a random manner from the box. The probability that both the parts are being good is what? So I hope we are very clear in the previous question. So now directly we can see that overall there are 25 parts, of which 10 are defective and let's say 15 are non-defective. And now 2 parts are being drawn. So there are 2 parts being drawn, of which we want both being good. So being good is like non-defective. So that means we need both to be non-defective and 0 to be defective. So this can be done in 10C0 into 15C2 divided by, this is how much? 25C2, right? Because we are picking 2 items out of 25 items. So we can calculate this. This will be coming around 105 by 300. So you can take common 15. So that will be 7 by 20. So that is option A. Now we have already discussed in detail in the previous question. So in this question we can directly frame it, put the values and find the final value. So I hope it is very simple. Of course, it is very similar, and you are clear with this. Clear? Now, the next question is, a box contains 4 red balls, 6 black balls, 3 balls are selected randomly. I hope you can do this directly. I can tell you the answer. I think 6. The answer is D. I'm not solving this. Answer is D. If you want, you can see that 4 red balls, you want the probability that 1 red and 2 black balls. So it is going to be 4C1 into 6C2 divided by 10C3. Let's not, I mean, we have already discussed the same similar question, so I'm cutting this short. Let's solve this. Let's see this. So we are into Poisson's distribution now. This question is from Poisson distribution. It says a traffic office imposes on an average of 5 number of penalties daily on traffic violators. Assume that the number of penalties on different days is independent and follows Poisson distribution. The probability that there will be less than 4 penalties. Fine. So first of all, the probability, we can write this x comma lambda will be given as lambda into e to the power of minus lambda x. Sorry, x. Fine. In this case, lambda, which is the mean value, is given as 5. In the first line itself, the average number of penalties is 5. So lambda is given to be 5 here, and we want that there should be less than 4 penalties. So what we are expecting is r to be less than 4. Now, being discrete, and there cannot be accidents in negative value, so the possibility is p of 0, p of 1. One second. This is Poisson's, right? So I have written the formula for e to the power of minus lambda to the power of x by x factorial. That was for the exponential function distribution. This is for Poisson, so we have to write it for Poisson. So e to the power of minus lambda to the power of x divided by x factorial. So r less than 4 is p of 0, p of 1, p of 2 and p of 3. So we need all these 4. So if you see, e to the power of minus lambda, which will be e to the power of minus 5, can be taken common here. So I'm writing e to the power of minus 5 outside, and in the bracket we will have lambda to the power of x. So 5 to the, what is x here? It is 0 by 0 factorial plus 5 to the power of 1 by 1 factorial plus 5 to the power of 2 by 2 factorial and plus 5 to the power of 3 by 3 factorial. This is the value for it, and this will come, whatever this comes, we'll see that. So we need to understand that when r is less than 4, it cannot be negative, and it has to be discrete also. So the possible values for r is going to be 0, 1, 2 and 3. This is important, right? Lambda is equal to 5 is actually the mean. It is given as the average value, and in the case of Poisson distribution, the mean is only the lambda value, right? This is also understood, and the formula for the probability is e to the power of minus lambda to the power of x by x factorial. So all we have to do is now calculate this. So this calculation, cutting short the calculation, this is going to be 0.265. So this is the answer for this case. So we are expecting less than 4 accidents. in a day. So the probability is 0.265, and less than 4 counts 0 accident, 1 accident, 2 accident and 3 accident also. I hope we are clear here. Let's see the next question then. It says the arrival of customer over fixed time interval in a bank follows a Poisson distribution with an average of 30 customers per hour, and the probability that the time between successive customer arrival is between 1 and 3 minutes is how much? So let's start with this. It is given in this case, of course this is a Poisson distribution. So for Poisson distribution, the mean value is given as 30 customer, let's say C, per hour. But what we are talking is in terms of minutes here. So the probability we have to find is in minutes. So what we can do is we can write it as 30 customers per 60 minute, and this can be written as 0.5 customers like per minute. Of course, so this is mu, which is also lambda in the case of Poisson distribution. Mu is equal to lambda, which is also equal to like this. So mu is equal to lambda in this case, which is 0.5 customers per minute. We have converted the hour rate per hour rate into per minute rate, right? Now we also know that the exponential distribution, which is given as f of t lambda into e to the power of minus lambda, let's say t, right? F of t, which is equal to lambda into e to the power of minus lambda t, gives the waiting time. I'm writing it here. It gives the waiting time of Poisson's occurrence. So we need that the waiting time should be between 1 minute and 3 minutes. So what we want is, let's say capital F, this was small f, so capital F is capital F, where t lies between 1 to 3. So why I'm writing equal to also in this case? Because this time is continuous. The time interval between the successive occurrence, whatever occurrence it is there, so that is continuous, right? This exponential function is continuous, whereas Poisson distribution is discrete. So this is going to be integration from 1 to 3 f of t dt. And what is f of t? It is lambda into e to the power of minus lambda t. And what is lambda? Lambda value is 0.5. So this is going to be from 1 to 3, 0.5 into e to the power of minus 0.5 t dt. Of course, we can integrate this. This will be minus of e to the power of 0.5 t. The limits are from 1 to 3. So this comes out to be, I'm writing it simply capital F equal to e to the power of minus 0.5 minus e to the power of minus 1.5. Considering this minus, I have changed the limits, the upper and lower limit, we have changed this. So now we have to find the value of this, that's it. E to the power of 0.5 minus 0.5 minus e to the power of minus 1.5. I can tell you the value that this is going to be 0.384. 34. So this is the answer. Mind it that this is the time between the successive occurrence of the Poisson's event, right? Poisson's occurrence, which is given by the exponential function, which is lambda into e to the power of minus lambda t, right? And now that we want the time between the successive occurrence to be 1 and 3, so we can integrate small f of t for t equal to 1 to 3, right? This is continuous, so we have to integrate this, and this comes out to be 0.3834 in this case. Clear? And also the mean value was given in, the rate was, average value was given in terms of per hour, whereas the time was given in per minute. So what we did is converting the hour rate into minutes rate. That's it. These two things were important here. Let's see another one. This is very similar to the previous question, and it says the traffic on a highway is moving at a rate of 360 vehicles per hour. So now the rate is, or I'll say the average rates, right? So let's say mu is 360, let's say vehicle for V per hour. But what we have to find is the probability that the headway between successive vehicle lies between 6 and 10 seconds. So they are talking in seconds now. So we can convert this mu in seconds. So this is going to be 360 vehicles per 360 100 seconds. So this is going to be 1 by 10 vehicles per seconds. So this is the mu, and of course this is the lambda, because we are into the Poisson distribution. So what we did is the hour rate was converted into second rates. That's it, because we need it in seconds. Again, in a very similar fashion like we did in the previous question, so we can again say that f of t in this case is lambda into e to the power of minus lambda t, and the lambda is 1 by 10. So what we need is capital F between 6 and 10. So capital F 6 and 10. So this becomes from 6 to 10 lambda e to the power of minus lambda t dt. This simply becomes minus e to the power of minus lambda t 6 10. So what is lambda? 1 by 10. So this becomes, I'm reversing the limits as per this minus sign. So this will become e to the power of minus 6 by 10 minus e to the power of minus 10 by 10. So all you need is to find the value, right? We have done this very similar question in the previous question in the method. So I'm not explaining very hard, and of course we can check the final value in this case. This value comes out to be 0.1809. Right? So again what we did is we changed the average rate into the per second rate, because the time lapse between the Poisson occurrence was given as 6 to 10 seconds. First thing. Secondly, for this Poisson distribution, we found that what is the exponential distribution, so that will help us to find the time lapse between the occurrence. So f of t is lambda e to the power of minus lambda t. Lambda is equal to 1 by 10 or 0.1. So the overall probability between 6 and 10 is nothing but the integration of f of t from 6 to 10. So that's it. We did this much. Very similar to the previous question. The number of parameters in the univariate exponential and Gaussian distribution is what? That is what they are asking. So I think this is very easy question. For exponential function, we know that the formula is lambda into e to the power of minus lambda x. So it is a single variable, single parameter. What is the parameter here? Parameter is lambda. So it is the number of parameters, so single parameter, that is lambda. Whereas in the case of normal distribution, f of x is given as 1 by under root of 2 pi sigma square e to the power of minus 1 by 2 x minus mu by sigma square. So in this case, what is Gaussian distribution is nothing but the normal distribution. So in this case, we have two parameters, lambda and mu both. Sorry, sigma and mu both. Sigma and mu. So that is two parameters. So that means we are going to have one parameter for exponential and two parameter for normal. So the option B is correct answer in this case, right? It was an easy question though. Let's see the next one. Let z be an exponential random variable with mean 1. So in this case, mean, which is mu, is equal to 1 is given. We should also know that for the case of exponential random variable, this is 1 by lambda. This is not lambda, this is 1 by lambda. But though it is 1, so mean and lambda are both going to be 1 in this case. And the cumulative distribution function is given. So cumulative distribution function is given. From here also we can find the probability density function. So if you want, you can say for exponential distribution, f of x is going to be f dash of x. F yani ki, that is capital F. So that is distribution of this function 1 minus e to the power of minus lambda x. So this is going to be simply e to the power of minus x. This is also okay. Otherwise, you can directly write the formula f of x is given as lambda into e to the power of minus lambda x, and in this case lambda is 1, so this becomes e to the power of minus x. This is also fine, that is also fine. So you can find it in any of the manner. Like if you remember the formula, you can directly write it like this. Otherwise, you can differentiate the cumulative distribution function to get the density function, right? df of x by dx to get f of x. Fine. This is also okay. So any of the method is fine. Now, what you want is the probability z greater than 2 given z is greater than 1. Right? So this can be done if we take, so now the conditional probability says that we can take probability of z greater than 1 as the new sample space and probability z greater than 2 as the event in this case, right? So this is going to be integration of f of x or f of t, anything is okay, f of x dx from 2 to infinity divided by f of x dx from 1 to infinity, right? So now that we have a new sample space, because the conditional probability changes the sample space, so this sample space becomes p of z greater than 1. So this comes out to be integration of e to the power of minus x. This is our f of x, so I'm integrating it directly as e to the power of minus x minus from 2 to infinity as, and numerator it will be minus e to the power of minus x from 1 to infinity. Of course, we can take this minus common. This is going to be, if you don't want, that is also fine. So using this minus, I'm reversing the order. So this is going to be e to the power of minus 2 minus e to the power of minus infinity divided by e to the power of minus 1 minus e to the power of minus infinity. So e to the power of minus infinity becomes 0. So this is simply e to the power of minus 2 by e to the power of minus 1. This comes out to be, I'm telling you the value, 0.367. You can calculate this, it is 0.367. Yes, so it is a fill in the blanks option, so 0.367 is fine, right? So what we did here is, we can find the density function in both the ways. The first way is knowing that the average value, mean value is 1, we can find the lambda, and from there we can find the density function, which is lambda into e to the power of minus lambda x. So this is e to the power minus x. We can also see that the cumulative function is given, and we know that density function is differentiation of the cumulative function. This will also give us e to the power of minus x. So anything is fine. Now the conditional probability that z is greater than 2, z is the random variable here. So z is greater than 2 given z is greater than 1. So z is greater than 1 can be taken as the sample space, whereas z greater than 2 can be taken as event. So this is event by sample space. That's it. So now that it is continuous, instead of summation, what we are going to do is integration. So integration of f of x. So what is f of x? E to the power of minus x. So the integration becomes e to the power of minus x minus. That's it. So I hope this is very clear. I mean, there is nothing much to explain now. So now that there was simple calculations, that calculation says the answer is e to the power of minus 2 by e to the power of minus 1. That's it. Let's move to the normal distribution or Gaussian distribution. So let's see some questions on this. Interesting. Let's see. It says a nationalized bank has found that the daily balance available in its saving accounts follows normal distribution. Fine. With the mean of rupees 500 and standard deviation of rupees 50. The percentage of saving account holders who maintain average daily balance more than 500. So what they are saying is mu is 500 in this case and sigma is 50 in this case. Also, they are expecting the value of x greater than equal to 500. So what is this percentage value? Percentage is how much? This is what they are asking, right? The mean is given, the sigma is given, the percentage value of x greater than or equal to 500. Now we know that the normal curve, something like a bell-shaped curve, let's say this is the normal curve here, and it is symmetric about the mean value. So this is x equal to mu equal to 500. This is x and this is f of x. We also know that being symmetric, this part and this part are all same. That is, this is 0.5 and this part is also 0.5. So 0.5 in the sense is the percentage value is 500. So do you see that this half is nothing but x greater than equal to 500 and this part is x less than equal to 500. So now that this part covers half of the curve, we can simply say that x greater than 500 will be 0.5 or 50%, right? We know that overall minus infinity to infinity f of x dx will be 1. So half of it is 0.5 and another half on the left half of this symmetricity is 0.5, right half is also 0.5, right? So it is going to be 50%. That's it. This will be the answer in this case. So we can directly solve it checking the mean value, but for a better picture I have drawn all this. Let's see this case. It says we have got two random variables. The first one, let's say x, it is already given x, with the mean value mu x is equal to 1 plus 1 and variance. So sigma x square is equal to 4. So we can also write sigma x is equal to 2. Whereas another variable is given y, random variable, normal random variable with mu equal to -1 and variance which is not known. That is what we have to find here. It is also saying that probability of x less than equal to -1 is same as probability of y greater than equal to 2. Using this, we have to find the standard deviation of y, that is sigma y. So with the different variance and different sigma value, mean values, what we can do is we can bring both the random variables to this common base, that is standard normal variable. Standard normal variable is where n is 0, 1, right? The mean value is 0 in this case. So what we can do is we can convert both of it into the standard normal variate. So this from x, we can say that z is going to be x minus mu x by sigma x. And now that we need x less than equal to -1, so z will automatically become z less than equal to -1 and mu x, which is -1, divided by sigma x, which is 2. That means we are looking for z less than equal to -1 here. Secondly, in y case, we need z to be equal to y minus mu y by sigma y. For your reference, I am mentioning it here. What they are looking for is, writing it here, x less than equal to -1. So I am writing it here, x less than equal to -1. Similarly, in this case, we are looking for y greater than 2 in this case. So using this, we can write that z is going to be greater than equal to 2 minus of -1 by sigma y. So you can say z is greater than equal to 3 by sigma y. Now this both having the common base standard normal distribution. So we are into standard normal distribution. That is n 0, 1. 0 is the mean value, 1 is the variance. So we have probability of z less than equal to -1 same as equal to probability of z greater than equal to 3 by sigma y. Now we know that for this standard normal distribution, let me draw this again. In this case, the mean value z equal to mu equal to 0, right? For standard normal distribution, the mean value is 0. And they say the probability z less than equal to -1. So let's say this is -1. So all the values on the left half of the -1 is similar to greater than 3 by sigma square, 3 by sigma. So this is 3 by sigma y, and this is possible only if the absolute distance of -1 and 3 by sigma y is same from z equal to 0. So I'll say -1 absolute value should be equal to 3 by sigma y, and this is possible when sigma y is nothing but 3. So this is the variance, sorry, this is the standard deviation of y. Sigma y is equal to 3, right? out of symmetricity in the standard normal distribution, what is on the left side of -1 is same as something which is right on the right of 3 by sigma y, because z less than equal to -1 is left half of -1 and z greater than 3 by sigma y is right of the 3 by sigma y, and both of being equal on this symmetric curve. This normal curve, standard normal curve, is symmetric curve, symmetric about mu equal to 0 or z equal to 0. So that means the distance of this -1 from z equal to 0 is same as the distance of 3 by sigma y from z equal to 0. So both of them are going to be 1 unit. So this -1 in this side means that this value should be nothing but, this 3 by sigma y should be nothing but 1. So 3 by sigma y being 1 means sigma y is equal to 3, right? Then only this is possible. So that means, do we have options here? Yes. So our answer is A, that is 3. Sigma y is equal to 3 in this case, right? So we have brought x and y normal random variable to the common base of standard normal distribution. Let's see next one. The length of large stocks of titanium rods follows the normal distribution with a mean of 440 and sigma of 1 mm. So we have to find the percentage of rod which lies between 438 to 441. Before solving this, we need to understand a very basic and regular thing which you come across regularly. Let's say this is our normal random variable. This is better. So what we know is, if this is mu, let's say x equal to mu, then if this is mu, this is mu minus sigma, this is mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. Let's say this is mu minus 2 sigma and this is mu minus 3 sigma. So what we know is the range of mu minus sigma to mu plus sigma covers 65% approximately, sorry, 68%. Fine. And a range of mu minus 2 sigma to mu plus 2 sigma covers 95.5 percentage, and a range of mu minus 3 sigma to mu plus 3 sigma covers almost 99.7%. So we need these three data here, and if you see in this case, I am drawing a simple line, not curve. If this is mu equal to 440, this is the upper limit is 441, whereas the lower one is 438. So do you see that this one is, if this is mu minus 2 sigma and this is mu plus sigma, because sigma is equal to 1 in this case, it is given, right? I hope I am clear. From 440 to 438 it is mu minus 2 sigma, whereas from 440 to 441 it is mu plus sigma. So we will take two part one by one. The first one is this range. So do you see that this range, this one is half of 95.5, because if mu minus 2 sigma to mu plus 2 sigma covers 95.5, that means mu to mu minus 2 sigma will cover half of 95.5. So I'm writing it 95.5 percentage by 2. In a similar fashion, using some, let's say green. In a similar fashion, this mu to mu sigma. So this range, what is this range? This is mu minus sigma to mu plus sigma, which is 68%. So this is going to be half of 68%, right? So this mu to mu sigma is going to be 68 percentage by 2, and overall you'll have to add both of them. So you can simply add them, and 95.5 plus 68% divided by 2 will be approximately 81.7 percentage, 75 or around that, 75, which is close to option A, right? So what we did is, on the left side they are going up to 2 sigma, whereas on the right side they are going only up to 1 sigma value. So from this general curve we have drawn here, we can see that mu minus sigma to mu plus sigma is 68%. So half of it out of symmetry, this half will be half of 68%, this half will be half of 68%. Whereas the second part, mu minus 2 sigma to mu plus 2 sigma, covers 95.5 percentage approximately. So half of it and half of it out of symmetricity. So what we did is, we took overall, I'll also shade this region. So what region we are talking of is this one. Right side we are talking about this region, whereas left side we are talking of this region. Clear? So this range is how much? Mu minus 2 sigma, whereas this is only mu plus sigma. I hope we are clear. We have divided the overall range into two parts, the left part from the mu and the right part from the mu. I hope this is clear now. So that's it. Overall it is approximately 81.75 percentage, which is closest to the option A. So option A is the right answer in this case. Let's see the next question. Two independent random variables, normal random variables, are given, and there is another random variable which is y equal to x1 minus x2. So this y equal to x1 minus x2 is actually a linear combination. Linear combination of two independent normal random variable, right? It is linear combination of two independent normal random variable. So because of this y is also going to be normal random variable. First thing. Secondly, a general form, using a general form, the general form is y is equal to c1 times of x1 plus c2 times of x2. So in this case you can see that c1 is 1 and c2 is minus 1. You can compare the result y equal to x1 minus x2 and y equal to c1 x1 plus c2 x2. So in this case, the mu value of y is given as c1 mu1 plus C2 mu 2. So this will become y1 and y2 both are 1. It is given here. So it is going to be 1 into 1 minus 1 into 1, which is 0. This is into 1, right? This is not 1.1. Secondly, this sigma y square is given as C1 square into sigma 1 square plus C2 square into sigma 2 square. So this comes out to be 1 square plus 2 square, which is 5, because sigma 1 is 1 and sigma 2 is also is 2. So overall, y is a normal random variable. Y is a normally distributed with mean equal to 0. We have found it here, and variance equal to 5. We have found it here. So option B is the right answer in this case. So B is the correct answer. Clear? B is the correct answer. Linear combination of two independent normal random variable. Let's see the next question then. So in this case, we have got uniformly distributed random variable between 0 and 1. So we know that for uniform distribution, f of x is given as 1 by beta minus lambda in the range of x lambda to beta, or let's say alpha. If you want it alpha, it is alpha. Alpha. So in this case, alpha is 0 and beta is 1. So that means f of x becomes simply 1 in the range of 0 to 1. And the standard deviation sigma is given as beta minus alpha divided by under root of 12. So this becomes beta minus alpha is 1 by under root of 12. So this is simply 1 by 12. Option A is the right answer. Right? We have taken out all the elements, alpha, beta, f of x, sigma, and everything is here now. Fine. If it was mean value, it would be beta plus alpha plus beta by 2. So that is not asked here, although. So this is it. Nothing much. Direct formula. This is also similar. Probability density function of a continuous random variable distributed randomly between x and y, where y is greater than x. So it is going to be f of x equal to 1 by y minus x for, let's write it small x. Small x, if small x lies between capital X and capital Y. So that's it. Option B is the right answer, and otherwise it is 0. So all we have to do is find the density function, which is going to be 1 by y minus x. Nothing much, a direct question. So this is also, I think, 1 marks question only. So the answer is B. Let's see the next one. It says y is distributed uniformly in the interval of 1, 6. Y. And the probability that the polynomial this has only real roots. So for function let's say f of x comma y, which is 3x square plus 6xy plus 3y plus 6 to have a real root or only real roots, we know that the discriminant should be greater than equal to 0. If it is equal to 0, we will have equal and real roots, and if it is greater than 0, we will have two different real roots, right? So we can consider the case of, let's say, greater than 0. So in that case, b square, which is b square minus 4ac, should be greater than 0. So of this function, in terms of x, like 3 is a coefficient, 6y is a coefficient, and 3y plus 6 is a constant when you are talking in terms of function of x. So b square will become 6y square minus 4 into, this is 3, into 3y plus 6 should be greater than 0, right? A function in terms of x. So this 6, I mean writing it like this, 3x square plus 6y times of x plus 3y plus 6 equal to, let's say, 0. So this is nothing but ax square plus by plus, sorry, bx plus c, right? So 6y is nothing but the coefficient b. So 4, 3, 12, 12, 3. So we can take 36 common here, and this will become y square minus y plus 2 equal to or greater than 0. From this we will have roots of y equal to, this will be minus 2 plus 1. So minus 1 and 2. So these are the roots. That means y should be greater than 2, as we want this function to be greater than 0. We are not going to talk about y, let's say, less than minus 1 or something like that, because the distribution here is given, y is uniformly distributed in the interval of 1 comma 6. So if we talk about f of y, it is going to be 1 by 6 minus y in the range of y lying between 1 to 6, and it is going to be 0 otherwise. So overall we can write that f of y is 1 by 5 for the range of 1 to 6, and it is 0 otherwise, right? This is a uniformly distributed function or variable in the range of 1 comma 6. So the formula says 1 by beta minus alpha. We have already seen in the previous question also. So 1 by beta minus alpha in the range of x greater than equal to alpha and less than equal to beta. So in this case you can say that alpha is 1 and beta is 6, sorry, right? So now that we want the value y to be greater than 2, the probability that y is greater than 2 becomes integration of f of y dy from 2 to how much? 6, because it cannot go beyond 6. The maximum value is going to be 6 in this case, although it was supposed to be 2 to infinity, but it cannot go beyond 6. So we are writing it directly as 2 to 6. So this is 2 to 6. F of y in this interval is 1 by 5 dy. So this becomes 1 by 5 into 6 minus 2, which is 4 by 5 which is 0.8 in this case. So this is the probability that y is going to be greater than 2, and for this y greater than 2, what we are going to get is the function of f of x comma y will get real roots of x, right? So 0.8 is the final answer. I hope this is clear. What we were looking for is real roots of x, and for real roots of x, the discriminant of this function in terms of x should be greater than equal to 0. Greater than 0. So this has to be greater than 0. B square minus 4ac. So from here we can see that this is going to be b, and 4 into 3 into 3y plus 6 will be b square minus 4ac. From here we found that the roots are going to be, for y the roots are going to be -1 and -2, but there is nothing, like we have no concern with y being in the negative part. Why? Because y is distributed uniformly in the open interval of 1 comma 6. So we are only concerned with y being in the range of 1 comma 6, and we are getting two cases. The roots are -1 and 2. So for this function being greater than 0, it can be either greater than 2 or it can be less than -1. So less than -1 is not of our concern. The only concern is y greater than 2. Also, now that this is given as a uniformly distributed function, so f of y becomes 1 by 6 minus 1. So that is 1 by beta minus alpha. Alpha is 1 and beta is 6, and otherwise it is going to be 0. So that gives capital cumulative distribution, that is y greater than 2 will be integration of small y, that is the density, integration of the probability density function from y is equal to 2 to y is equal to 6. This comes out to be, now that we have already found the f of y to be 1 by 5, so integration of 1 by 5 from y is equal to 2 to 6, which comes out to be 0.8. So 0.8 is the final answer here. I hope we are clear here, right? We are looking for the real roots of x that is possible when y is either less than -1 or greater than 2. But -1, y less than -1 is not of our concern. The only concern is y lying between the interval of 1 comma 6. So that is y from 2 to 6. That's it. So this was about the discrete and continuous distribution. We have seen binomial distribution today, hypergeometric distribution, Poisson distribution, exponential distribution, normal distribution, standard normal also, normal, that is Gaussian distribution, and uniform distribution. So all 6 distribution, these are the 6 distributions we are going to deal when you are like in the GATE examinations in the topic of continuous and discrete distribution. So practice more questions on this, and in the next class we are going to be moving into the next topic, which is maybe complex or something like that, right? We'll see in the next class. So for people who are joining today fresh, they can visit the entire playlist which is already in the description. Go through the entire playlist, watch other topics, other doubt classes also, and use the promo codes to buy your subscription. Fine. Okay then, keep learning, have a happy Sunday, and prepare for your GATE examinations. Thank you. Bye bye.